Alright, so in this video, I'm going to solve the equation 1 to the power of x is equal to 2. So, before we even start solving this, if, let's say x is equal to 1, then I have 1 to the power of 1, which is equal to 1. And if x is equal to 2, then I have 1 to the power of 2, which is also equal to 1. And you can go even 1 to the power of 10 is still equal to 1. So you may be thinking, what possible value of x can make 1 to the power of x equal to 2? So let's try solving this. What I'm first going to do is start by taking ln of both sides. So I get ln of 1 to the power of x is equal to ln of 2. And ln is the same thing as the natural log. And the reason I took the ln on both sides is because it comes with a property that states that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln 2. And you may be thinking, we could just divide both sides by ln 1 and x would equal ln 2 over ln 1. However, the only problem with this is that ln 1 is equal to 0. And remember, anything divided by 0 is undefined, so this would be undefined. So we know that this equation has no real solution, but it could still have imaginary solutions. So to actually solve this, I'm going to use something known as Euler's formula. And basically what this formula is if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know to many of you watching this video, this may just sound like a bunch of gibberish, but just hang on. So let's say that theta is equal to 0, right? Say that theta equals 0. So now I get e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. Cosine of 0 is 1 and sine of 0 is 0. So I get this all is equal to 1. Now, what if we say theta is equal to 2k pi? And k is just a substitution for all real numbers. So now I get e to the power of I times 2k pi is equal to 1. Because all we did was we just substituted theta in for 2k pi into this same thing. So now, because this is equal to 1, we can remember our first equation, which we started with 1 to the power of x equals 2, we can substitute in this for 1, meaning I get e to the power of I times 2k pi to the power of x is equal to 2. So just think of this as 1. So I have basically 1 to the power of x equals 2. And now, with this, I'm going to take the ln, or natural log, on both sides. So I have ln e to the power of I times 2k pi to the power of x is equal to 2. So I'm going to now bring this x down using the property of natural logarithms. So I get x times ln e to the power of I times 2k pi is equal to 2. is equal to ln of 2, because if you take ln on one side, you have to do the other side. And now I can also move I times 2k pi to the front. So I have I times 2k pi times x times ln e is equal to ln 2. ln e is simply equal to 1. So I get x is equal to ln 2 over I times 2k pi. And now I'm going to multiply this by I over I. So I get x is equal to negative I times ln 2 over 2k pi, because I squared is negative 1. So this is my solution. Alright, so in this video, I'm going to solve the equation x to the power of 4 is equal to 1. So to solve this, I need to find the value of x. So I'm going to subtract 1 on both sides. So I get x to the power of 4 minus 1 is equal to 0. Now from here, I'm going to rewrite this as x to the power of 2 times 2 minus 1 to the power of 2 is equal to 0. And the reason I did this is because now I can use the property a to the power of m times n is equal to a to the power of m to the power of n. So in this case, x to the power of 2 times 2 is equal to x to the power of 2 to the power of 2. So I have x to the power of 2 to the power of 2 minus 1 to the power of 2 is equal to 0. And now another property I can use is a squared minus b squared is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I get x squared plus 1 times x squared minus 1 is equal to 0. Now this gives me two equations. I get x squared plus 1 is equal to 0 and x squared minus 1 equals 0. So let's first solve x squared minus 1 equals 0 because it's more simpler than x squared plus 1 equals 0. To solve this, I'm going to first add 1 on both sides. So I get x squared is equal to 1. And now I'm going to take the square root on both sides. Square root of x squared is x, and I get x equals positive or negative 1. Now for x squared plus 1 equals 0, I'm going to subtract 1 on both sides. So I get x squared is equal to negative 1. I'm going to again take the square root on both sides, but this time I get x is equal to positive or negative square root of negative 1. Now if you guys already know, the square root of negative 1 is equal to I. So I get x is equal to positive or negative I. So my four solutions to this problem are x equals 1, x equals negative 1, x equals positive I, and finally x equals negative I. So please make sure to like the video, subscribe, and please also share this video to your friends if you liked it. Thank you.